Okay, hello everyone. Today we are going over section 4.4. It is about solution for non-homogeneous second order differential equations. Let me start with reminding you about homogeneous differential equations. So last time we did something like this: ay double prime plus by prime plus cy equals 0. And we said what is special about this, it is second order now, yeah, and it is linear, yes, linear, yeah, and constant coefficients a, b, and c are constants, yeah, and the last thing, it is that zero here, the zero here give me homogeneous. Yeah. Now, and we said if we have all these four parts, then you change this to quadratic equation and you can solve it and get your y. Then last time we said you can just go and change that thing to ar squared plus pr plus c equal 0, right? And then you go and get your solution. Your solution finally, it is one of the three cases, two different real roots, or two similar real, or one real root, or two complex roots. And finally, you need to get two solutions for the second order differential equation, and you use them to build your general solution, yeah? C2, Y2. Since this is coming from homogeneous differential equation, for this reason I will start, because today we're gonna go with more general case, then I will start writing this as YH. YH means Y homogeneous. Now, what is the difference between this and the new section? It says I will drop that condition. So what if not? If not. If not means, let me just go here and write the differential equation now. We have something like ay double prime plus by prime plus cy equal I'm going to say here f of x or f of t. So I'm saying here that the independent variable is x. I could consider it as t also. Doesn't matter which one you consider, it is just replacing the independent variable with x over or t. Now, how to solve this differential equation? I'm going to tell you to solve this, to solve it, you need to go with 3 steps. First of all, you solve the homogeneous. Step number 1. Step number 1, solve the homogeneous, which means you make it equal to 0, ay double prime plus by prime plus cy equal now 0, right? Because I'm calling it homogeneous, and call this solution. So, and you will get here, you will get something y equal to c1 y1 plus c2 y2, right? So you're going to get two solutions, and you use these two solutions to build up your solution, your general solution for the homogeneous. So let me just show you that the name here, as we said, we're going to call this YH, right? This is YH. So this is the solution for the homogeneous part. Next, step number 2 will be to go and search for a particular solution. So step number 2 will be to find one solution, or we call it particular solution, for what? For the full thing, which is y particular. I'm calling it here, that p there, I'm calling it y particular, right? So that p here, it is y particular, right? Y particular, which is a solution for what? It is solution for the full thing, which is a y double prime plus by prime plus cy equal to f of x. So you keep f here and you find for one solution, and today we will discuss this in details, and I will give you the way for finding y particular, because this part here I already discussed in 4.2 and 4.3. So 4.2, 4.3 is giving you a homogeneous solution. Now this section is 4.4, yeah? Section 4.4 is discussing this case. And step number 3, write your general solution, write the general solution as y equal to y homogeneous plus y particular. Yeah? The homogeneous is the solution for step number 1, and y particular is the solution in step number 2. Now, in this section, I will discuss the case when you have the right-hand side, or the function f of x, nice function. So this section is discussing only nice functions, f of x. So here's okay. So step number 2. So today, how to find y particular. Yeah. So y particular. So in this section we will discuss. In this section, we will discuss the case when f of x is nice function. When I say nice function, then nice functions, I mean by nice functions, they are either exponential function, or sine function, or cosine, or polynomial. So these are the only functions that I'm going to consider nice in this section, and I will be able to find their y particular. So this method, how to find this, I'm going to depend on indeterminate coefficient method. So it is called indeterminate coefficient method. So here is the answer. We will use indeterminate coefficient method. This method will work only if you have constant coefficients and you have f of x. So this method will work. So work only if we have constant coefficients and f of x nice. Okay. let me explain the method for you. I will explain the method. So indeterminate coefficient method. So here is the indeterminate coefficient method. Method. What is this method? It says that it is a method of guessing the y particular. So this method is saying you can guess y particular. So y particular, you can get it by guessing. So you can guess. Yeah. How you gonna guess this? I'm gonna give you an example, and then I'm gonna give you a table how to guess any y particular. If your function f of x is a nice function. So let me start with an example. Here is the example. So let me go with an example which says you have one example. It says solve the differential equation. Which differential equation? Here is the differential equation. Y double prime plus 5y prime plus 6y prime equal to ex. How are you going to solve this? Now, here's the solution. As we said, we're going to do step number 1, solution. Step number 1, first solve for the homogeneous. So homogeneous. So, or let me just tell you at the beginning, your general solution will be y equal y particular, or let me start in order as before, y homogeneous plus y particular. Yeah? Now, how to do y homogeneous? To find y homogeneous, you need the right hand side to be 0, right? So you need to go with y double prime plus 5y prime plus 6y prime, 6y, sorry, this is 6y. It is not y prime, it is 6y equals 0. So when I put 0, then this is homogeneous. Now this is, you go back now to section 4.2 or 4.3, right? How are you going to do this? Then you know this is r squared. You replace y double prime by r squared plus 5. And this is r. And this is 6 times 1, right? Then you get 0. Now when you solve this, let me solve this here. So you're going to have r plus 2 times r plus 3 equal 0. Then you get r1 is minus 2, yeah? And r2 is minus 3. And from the first one, you get y1, which is e power. What is the variable here? Now, we know the independent variable. You cannot consider like before. I don't know it, then I can consider it t, or I can consider it x. Now, from f of x, I know the independent variable. So you cannot consider t here. So it will be e minus 2x. And y2, from this one, you get y2. It is e minus 3x. And from these two, you can build now, I don't call it y as before. Now I have to call it y homogeneous. Then in this case, c1 times y1, so you get e minus 2x, and plus c2 e minus 3x. And this thing that you get here is the homogeneous solution for the differential equation. So the homogeneous part. Now look at the homogeneous part. By the way, homogeneous part will have c1 and c2 constants of integration, but not the particular solution. So you will see the particular solution in a minute. So homogeneous, so this is homogeneous, solution, right? The homogeneous solution, you will have C1 and C2. Let's see the y particular now. The new thing will be the y particular. So let me keep this for a moment, and then now step number 2. So this solution here, of course, it will be here. So we said here we have y equal y homogeneous plus y particular. Now I found this part, right? You take that thing here, that thing there, and you put it here, yeah? You put it as the homogeneous part of your solution. Now let's go and do y particular now. Y particular, I need to guess my solution here, and I will not tell you now how I guessed my solution, but I'm gonna say I will assume that y particular is of the form a e x. So I didn't change the power here, so we have the power 1 times x, I keep 1 times x. But here we have the number 1, yeah? But now I'm changing the number 1 to a, right? So I didn't change the exponential part, but I changed the number or the coefficient of the exponential. Now, let me now, what is special about y particular? Y particular is not like y homogeneous. Y homogeneous, if you plug it in the homogeneous part, then you will get 0. But y particular, if you plug y particular in the non-homogeneous part, so this is solution for non-homogeneous, yeah, non-homo, yeah. Now let me go and plug it inside that equation. Now I know what to plug for y, but I don't know what to plug for y prime. For this reason, I wanna differentiate. Then I will get again a times ex. Y particular double prime also I need here. Then I will get a ex also. Now if you plug here, let me just show you. This is the equation. So now we get aex plus 5 aex plus 6 aex equal ex, right? Now you need to solve for a now. Solving for a. Solve for a. This is why we call it indeterminate coefficient. You need to determine the value for a. So indeterminate coefficient, determine the value for a, determine the value of the coefficient, right? This is why we give it that name. In this case, if you add all these things, then what you're gonna have? So you're gonna have 12a, so let me go here. I'm simplifying first. So I get 12a ex equal ex. Now I know that I can divide by ex, yeah? Because ex cannot be 0, right? Then I will have 12a equal to 1, right? And then if you solve for a is 1 over 12. Now we know what is a. I can take the a and plug it here, right? And then I'm getting y particular, yeah? So I got y particular here, so I know what is y particular. So I'm gonna write my y particular now. Y particular is 1 over 12 e power x. So this is the y particular. Note that y particular has no constants of integration, so no c's in this, no constants. No C1 and C2, no C's, yeah? No C's, no C1, C2. So from now on, when I see the solution, now what is the general solution now? General solution for the differential equation is y equal y homogeneous, I got y homogeneous, C1 e minus 2x, I think, plus C2 e minus 3x. This is the homogeneous part, and now I'm writing the particular part, 1 over 12 ex. Just to show you what is going on here, that part here is y homogeneous, right? And that part here is y particular. So this is the general solution. Some people, they are writing it as y general. Y sub g means y general is y homogeneous plus y particular. Now the question is, how do you know that, how do you choose your y particular? How do you know that your y particular should be unknown constant times exponential with the same power? The idea is very simple. The idea is very simple. Just imagine that this thing is a machine or a function. So this is a kind of a function. Now let me show you what is going on. This is the output. Yeah, output. Now imagine that you have a function and you don't know what is the input here, and you are getting the output. So input is y particular, yeah, y particular. And the output is e power 1x, right? This is the output. This is your f of x, right? This is f of x. So the output is f of x, the input is y particular. What you're going to do with y particular, you're going to differentiate twice, yeah? And then you add 5y particular prime plus 6y particular. This is what you're going to do. So which function? You're going to differentiate it twice, add 5 times the first derivative for that function, and add 6 times the function itself and get exponential. So it seems to me that you need to start with exponential so that when you differentiate it and adding it to itself or a multiple of itself, you will get exponential. So the only solution here must, so I'm going to say must be exponential. Yeah? Even the exponential, if you start with exponential here, power 1x, then this exponential should have 1x, because when you differentiate, then you are not losing the power here for the exponential, so you keep the power for the exponential. The only thing that I'm not sure about is the number here. So the number here is 1. So let me go with this. So the only thing that I'm not sure about is the number here. I have 1. So I'm not sure what number will be there. For this reason, I'm assuming A. So assume this is unknown. Unknown coefficient. And the method is coming to determine this value. Determine A. So your job, the job will be to determine A. For this method, for this reason, we call it indeterminate coefficient method. Yeah. So here is just the idea, and now I'm going to give you a table and show you what or how to guess your y particular function, and then to use indeterminate coefficient method to find the coefficient for that guess. Let me go with a table now. So table here. So we have a table how to guess your y particular. Yeah. Now this will be only for nice functions. Yeah. Nice functions means if you have a machine like this, right? And here, if it is nice here, nice, the output is nice, then I can guess. So you need to guess the input, right? You need to guess the input. This should be nice. If you know that this is nice And you know that your machine is nice. This is nice because you have constant coefficients. Constant coefficients. So it is a constant coefficient differential equation. So it is a nice differential equation. And the output is nice. Then you can guess the input. Yeah? You can guess the input here, y particular. Yeah? So what are the nice functions that you will be able to guess the y particular for them? F of x and here y particular. Let me start with something like this. So I'm going to say I have y particular here, e power k. Sorry, this is the function, the nice function. So exponential is a nice function. So you have k here, k times x. And whether you have a number here or not, say I have a number here, right? Number times here, k. Let me call this k1 for example, and here k2. And k1 and k2 are known. Here k1, k2, anything here, any constant here, any constant here, any constant is known. Any constant is known. Yeah? So this side, any constant I'm giving, it means it is known. It will be 3 and 2 and so on. But in this side, constants are unknown. So constants are unknown. So in your case, the constants will be unknown, but in this thing, the constant will be known and given. So when I say known, means given in the question, given. Yeah, this means given. So if you have something like this, 3 and 2, then how you gonna guess your y particular? Let me write for you y particular. So y particular here will be, you will not change the exponential, it will be k1 and x, nothing changed. This will be known for you. Yeah, if it is known here, then it will be known. But here, I'm gonna have a. And you need to find a. So the next job will be what is a, right? So you will ask yourself, what is a? The only trouble here is if there is a match between y particular and y homogeneous. What if k1 here is a root if okay, let me write like this. Here k1 is not a root for the quadratic equation. Provided, so this is a condition, so we need k1 is not a root, because always when you have roots like r1 and r2, then you write exponential r1x. I'm afraid that this one is r1, so this means k1 is not r1 and k1 is not r2, right? Then this will be true, right? But if k1 equal r1 or r2, then you're gonna have a match between y homogeneous and y particular for this case here only. For this case only, then you need to adjust your y particular to be. Now what you're gonna have a x e k1x or a x square e k1x. This case will be only, so this case here only if R1 equal R2. If R1 equal R2, then you go with the second case. You need to adjust by multiplying by x squared. Now the question is, why you need to do this? So this is the first nice function. This is the first nice function. It is k2 e power k1x. Now I said this is the good choice. You don't change the exponential, but you change the coefficient. It is a number here. You consider it as a constant that you need to find its value. Now if this constant here, k1, it happened that it is one of the root for the quadratic equation in the homogeneous, right? When you are doing your homogeneous. Yeah, and then it happened that it is one of the two roots, then you need to adjust your y particular. And if it is not one of the roots, then you keep your y particular as it is. So this is your f, right? And this thing is your y particular. Just for the first time, I'm gonna write it like this. Okay, now let me show you one example. Here is one example. It asked for solve the differential equation. Yeah, which differential equation? I'm writing here y double prime plus 4y prime plus 4y equal to 2 e power minus 2, and I'm writing t now. I'm writing t. So I like to change the independent variable so that you can get the idea if the independent variable is changing. Solution. So you need always to check that here you have not 0, so not 0. This is not 0, so not homogeneous. You have constant coefficients, right? You have second order differential equation, and it is linear. So linear second order with constant coefficients, but non-homogeneous. So not homogeneous. So what should you do here? So for sure, this is going to give you an idea that you are going with 4.4 and even 4.5. Yeah, the sections, because 4.5 also is coming to ask a similar questions. So first of all, you see the general solution has the form y equal to y homogeneous plus y particular. So let me change the color of one of them, or so let's go with, this is the y homogeneous, yeah? Y homogeneous. So I'm just tracking the y homogeneous first. Y homogeneous, how you will find your homogeneous solution. This means you make that thing 0, right? Then you have y double prime plus 4y prime plus 4y equal 0. So the idea is coming from here. So making this 0. Then you go with this thing to the previous two sections, which says make this r squared, make this 4r, make this 4 equal 0. Solve for r, then you get r plus 2 times r plus 2 equal 0. Then you get r equal to minus 2 is the only one solution for this quadratic equation. Now from this one, you could get your y1 as e minus 2. Now, what is the independent variable? It is t. So I'm going to put t here, yeah? And then how you get your y2? y2 is you need to adjust your y1 by multiplying. Now you don't multiply by x, now you multiply by t. You multiply by the independent variable. Now you go and check section 4.2, right? 4.2, when you have multiple root, yeah, or multiple root, then you need to generate y2 from y1, and I told you for now take it as multiplying with the independent variable. And in the future, I will show you how to find y2 from y1. Next, from this thing, you can generate your y homogeneous as C1 e minus 2t plus C2 t e minus 2t. Good. So I got here the y homogeneous, and I know that the y homogeneous, this guy, will go there, right? And then I need the y particular, so the second solution, the y particular, here is the y particular. How are you going to find y particular? I told you in the table that if you have on the here, so you have f of x here equal to 2, so it is not f of x anymore, it is f of t, right? F of t, yeah? It is 2e minus 2t. It is just changing the independent variable from x to t. Now, I told you that the exponential will stay as it is. So you're going to get e minus 2t, right? The only thing that you are not sure about is that thing, which is the 2. Then I told you, you put a constant called a. And this thing is a first guess. So this is y particular, is my first guess. My first guess. This guess is a bad guess. I'm going to tell you why it is a bad guess. So I will show you that this is not working. So this work here is just to justify that this y particular, this y particular is not good. Why not good? I don't know. I'm going to show you. Now, first of all, differentiate, so you need to plug this inside the differential equation. So you need y particular prime, yeah? And you need y particular double prime. So you get minus 2 a e minus 2t, right? Yeah, you get this thing, right? And then you do y particular double prime, and you get 4a e minus 2t. Good? And you go and plug in that equation. You're going to have 4a e minus 2t plus, yeah, plus now 4 times y prime is this thing, minus 2. So I'm just here writing the equation, that equation, but I'm replacing y particular here, right? Yeah? And then what I'm going to have, so this is not a part of the question, but I'm saying that y particular is a solution for that differential equation. So minus 2a e minus 2t, and the final thing is 4y. Now I'm writing 4y, this is 4, and you have a e minus 2t equal to 2e minus 2t. So now what I'm going to have here, 4 minus 8 plus 4, I'm getting 0, equal to 2e minus 2t. So mathematically, this is impossible. So I'm getting 0 equal a function which impossible, this never. So never happen, never. Yeah, never happen. This means that mathematically this will not work. Mathematically not true. So mathematically not true. This means that your first choice is not good. So this means that my first guess is not good. Not good. If you go back to my table, I said if you go to that thing here and you compare it with R1, what is R1? It is -2. And what is R2? R2 really is the same, yeah? If it is either R1 and R2, then you need to adjust. This means they are equal. If they are equal, then y particular first guess will not work. You need to adjust your first choice. How am I going to know if I should multiply? By multiply by independent variable. How many times? It depends on the multiplicity. If you have -2 two times, so R1 equal R2 equal -2, this means that the root is appearing twice. So this means you multiply by t squared. Yeah? But, okay. But if you have, so this means that we have one root. One root, then you multiply by t squared. But if we have two different roots, then you multiply by t. Multiply y particular, you adjust or multiply first. So when I say here, multiply y particular first guess by t or t squared. So it depends on what the roots. If the roots is one real root, you multiply by t squared, and if you have two different roots, then you multiply only with one t. So why you are doing this? Just to tell you, I'm trying here what you are trying to do. So here you are trying. So what is this? I'm just asking here a question. Why you are doing this? So I'm trying here. Let me write for you. So try. So make y particular independent from y1 and y2. Yeah. So let me show you. So I'm gonna just explain, but I will go to the solution and show you the details. For example, when we say independent, then you need to go with something like this. You go with y particular divided by y1 is a constant, so you are getting a constant. You make this equal t, then you need y particular equal t times y1, right? So I'm multiplying by t. But if it is happening also that if y2 equal to t times y1, then y particular is the same. Then y particular over y2 will be the same, will be a constant. Then I need this to equal another t, right? Then you will get y particular is t times y2, and you get t squared times y1. Yeah. So this case is happening. This case is happening if you have just one r. If you have one r, then you adjust y2 or you build y2 as t times y1. Then they're going to be a match between and if you build y particular with one t also, then you are building them in the same way. They will match, and you need to give two linearly independent. Then you need also this to equal t. Then you need to multiply y1 with t squared to get y particular. Anyway, so this is just to give the solution more or to make it make sense for you, then this is what we are doing. So we said I'm going back to the solution. All that explanation is not a part of the solution, but we were trying to do y particular. So here is the right solution, right y particular, yeah? So this is the right part, yeah? You go with y particular, and this is a e minus 2t, we said, right? And then we discovered that this is the first choice. Now, since we have one root, so since we have r equal minus 2, and it is the only root, one root, the only root for the quadratic, then, and there is a match here, equal, yeah, then because it is one root, you need to multiply by t squared. Then y particular is a times t squared e minus 2t. Again, because you get y2 by multiplying with 1t, then you need to get y particular by multiplying by t squared. Now, if someone goes with 1t, again he will get mathematically untrue, and he will be mathematically untrue because he will get 0 equal a number. So if someone tries something like y particular equal at e 2t, then this will give me 0 equal a number, and this is not good, yeah? So even this choice is bad, so the good choice is this thing, and now I need to determine the coefficient. It is called the method of indeterminate coefficient. So find A using indeterminate coefficient, right? Now, how are you going to do this? I have a differential equation there, and I need to plug for y. So let me write the differential equation here for you. It is y double prime plus y prime for y prime, right? Plus, I think 4y equal to, I don't remember, maybe it was 2e minus 2t, right? Now, let me go with this thing. So I know what to plug for this, and I know what to plug for that. No, not yet. I need to find y particular prime. Then this is a product rule for this thing. Then you get a times 2t times exponential minus 2t plus, and then a t squared, yeah, and minus 2 times, I'm doing here the chain rule, right? So this is the first derivative, and I like to make it just, maybe I take e minus 2t as a common factor. I will tell you why. Here I'm getting 2at, and here I'm getting minus 2a and t squared, right? And even I can take the a if you like. I can take even the a here as a common factor, and I can take even the 2 as a common factor, yeah? And I will get this, yeah? I will get this minus. Why I did this? Because I need to find y particular double prime. I need to plug here for this, and then I need just to use the product rule one time. Here product rule, here another product rule. Now I have one product rule, right, for differentiation. So I get 2a minus 2, you get minus 4a minus 2t, right? And here you leave the second one, and then you leave the first one, 2a e minus 2t, and you differentiate the second one, and you get this, right? Now, we need to plug in the differential equation. here is the differential equation, and I'm just trying to plug for this one first. Here is what I'm gonna get for y particular. Y particular double prime is this minus 4, yeah, minus 4 e minus 2t, and then t minus t squared, yeah, and then plus 2a e minus 2t, yeah, and then 1 minus 2t. All that thing is this thing, right? Then I'm writing now this thing, yeah, this thing. Now this is the 4 times that thing, which is the first derivative, 4 times this thing, 2a e minus 2t, and then t minus t squared. So this is just the first derivative multiplied by 4. And then the last thing is 4 and times y particular. What is y particular? It was a t squared e minus 2t, and the other side of the equation is 2e minus 2t. Now I can divide by this thing and get rid of this thing from now. So I can take this, that. I'm dividing over that thing and I'm getting this. Now let me just write here, we have a constant which is 2, right? So we have 2 here. And on this side, let me show you what we have. So we have a t squared here. Do we have any other t squared? Yeah, we have another t squared here. And another t squared here, right? Another t squared here. Yeah? Then I'm going to have all together here 4a. So I'm taking t squared here. And there is a coefficient for t squared. I'm getting here 4a from the first one. And I'm getting from the third term here, 8a. So here minus 4a, sorry, the first one, oh, it is minus times minus plus, right? This is plus. But here I have minus times this, minus 8a, right? And the last thing here is 4a. So for t squared, I have this coefficient. Let me go forward now. Yeah, forward. Now, let me go with the second one. The second one here is the coefficient of t. Here is t. And then for t here, if I take a, yeah. So for this one, for example, I'm getting 0, right? So this is 0, right? And now also for t, I think you will get 0. Let me see for t. Minus 4a. Yeah? And then another here, another minus 4. Yeah? And another 8a. Yeah? And this is times t. And the last thing, which is the most important one, is the constant. So constant here, we have 1 here, 1 times 2a, you get 2a, right? Yeah? Now, this is also 0. So it is kind of 0t squared, 0t, and 2a equal a. Now it is clear that constant equal constant. So constant equal constant. So these should be equal. So 2a should equal to 2. Then a should be 1. So a is 1. Now if you get a, then you already got what? The y particular. So now you go to y particular. Here is the y particular. It will be, it was a t squared e minus 2t, right? But I know what is a. A now is 1, right? So it is 1. Now you got y particular and you got y homogeneous. So now if you go now and build your y, which is y homogeneous plus y particular, and remember that this thing here is the general solution, right? This thing will be C1 e minus 2t plus C2 t e minus 2t, and then I'm getting here t squared and e minus 2t. Now let's check here. So the homogeneous part here is the one that has the constant C1 and C2, right? And the particular is the one that has no C's, right? And now these three parts should be linearly independent. So 1, 2, and 3 should be linearly independent. Are they linearly independent? Yes, because this one, if you divide over this one, you get, or this one divide by this, you get t. This divide by this will get t. This divide by that will get t. Will get t squared. So if you go y2 over y1 is not constant, you go also for y particular divided by y2 is not constant, and if you go with y particular divided by y1 is also good. All these things are not constants, So we are good, and we are now, we have here what? This is the general solution. So this is the general solution for the differential equation given. So let me give you another function, another nice function. So I'm going back to that table. Now we know what is the solution if there is a match between y particular. So here is a remark. Before going with that table, it is kind of, we have a remark, says if any match between y1, y2 and y particular is solved by multiplying by either t or t squared. And I'm considering here t is my independent variable, yeah, independent variable. But if the independent variable is x, then you go with x squared if my independent variable is x. Now back to that table, and I will give you the second function, second nice function. So we have that table back. So that table back, f of x. And here is a guess for y particular. What if you have a polynomial? Polynomial with known coefficients. Yeah, so this will be, I'm writing with known coefficients. This is as a remark for you. So the question will give you a known coefficient for the polynomial, right? It's a given polynomial. Now, how you wanna guess y particular? I will say here, you choose same degree polynomial with unknown coefficients. Yeah, and your job will be to determine these coefficients. So then determine these coefficients. So let me give you an example here. Suppose that here's an example just to check if you understand here. Suppose that I'm giving you a differential equation like here. Let me write in red here. Here's an example here, simple example. It says I'm giving you y double prime plus y equal to, say I'm giving you 2t squared plus 1. Now we know what is the function here, so I'm saying here the function is x, but doesn't matter whether it is t or x, yeah? So I'm going with t here. So what you're gonna do, this is your f. I'm not considering the y homogeneous, I'm focusing on this table only on y particular. How you're gonna choose your first guess for your polynomial. So here y particular will be, this is a first guess, so your y particular will be a second order polynomial. So you will have t squared, and will you have t or not? Now I'm going to tell you now t, and you will have the constant term. So you have 3 terms here, right? 3 terms. Now here the coefficient of t squared is 2, but for you here it is undetermined coefficient, then you call it a here. Now the coefficient of t here is 0, but for you it is unknown, you call it b. And here the constant term or the coefficient of t power 0 is 1, but for you it is unknown. So here this is a first guess. Why I'm calling it a first guess? But because what do you mean by a first guess? I'm afraid from one thing, what if, so for this one it is a first guess and final guess. So it is good. So this will be good. So I'm saying it is the first guess, and it will be the final guess. Now, why you are saying first guess? Sometimes will there be a match between the polynomial and the y particular? Yes. So what if here? I'm gonna write it as a remark. Sorry, it is already written there, remark. So remark, if r equals 0 is one of the roots for the homogeneous part, the quadratic equation, the quadratic. Now this means that when you go with that r, say r1 equals 0, or r2 equals 0, doesn't matter. Then when you go with y1, it will be e power here 0t, right? 0t. And this means this will be 1, right? And then I don't care what is the second solution. When you build y homogeneous here, y homogeneous, it will be c1 y1 plus c2 y2. Yeah, then you're gonna have c1 times 1, you get c1 plus c2 y2, right? Then look at this part here, and look at that part, the c here. Fortunately, in this question, we don't have this case because I'm going to solve this in details now. We're going to solve it in details. But suppose that the equation I'm changing here is if you have y double prime plus y prime equal to 2t squared plus 1, right? So this is different from that one, yeah? Let me solve both of them. In this case, they will match, yeah? But not in this case, yeah? If they are matching, then you need to adjust, then your y particular need to then match, then y particular here, y particular should be adjusted multiplied by t. So First choice is not working, second choice will work. Second choice. Yeah, then the first one will give you a mathematically untrue case. Okay guys, let me just show you how to solve that example now. So I will go back to that question here. It says, example, solve the differential equation. Which differential equation? I will solve both. This one, y double prime plus y equal to 2t squared plus 1. Now if you want to solve this as a solution here, solution, then your y, which is the general solution will be y equal y particular plus y homogeneous, right? If you want to go with y homogeneous, I will go very fast with this one. You will go with r squared plus 1. So let me write y squared, y double prime plus y equals 0. Then you get r squared plus 1 equals 0. Then you get r equal plus minus I, right? Plus minus I. Yeah, you go and say calculator here, calculator. I don't want you to focus on this part. I want you to focus on something else. So here you have 0 plus minus kind of 1 times I, right? Not kind of, it is sure that thing. So this is alpha and this is your beta. And when you go and build up from this, y1 or y1 is just that thing, e power 0. Now what is your variable here? It is t, right? 0t cosine beta is 1t, right? And y2 will be e0t sine 1t, right? And in this case, I'm getting sine and cosine because that thing is just 1, that one is 1. Then if you want to get y homogeneous, it will be c1 cosine t plus c2 sine t, right? So I got the homogeneous part and I know what to put there, right? But now let's go to y particular. Y particular. So I need to erase all that thing. Yeah. Here is the y particular. Y particular. To find y particular, then you go for f of x here. So you have our f of t. This is f of t. It is polynomial. And polynomial of degree 2, then I have to consider polynomial of degree 2. And we said the good choice is at squared plus bt plus c, right? Now you go and compare here, compare that with that. Is there anything, is cosine independent from t if you divide this over that? So each term should be different from each term here, right? Cosine is different from t squared, different from t, different from c. Sine different from t squared, different from t, different from c. For this reason, this choice will work. Then you need to go with y particular prime, then you get 2at, and you go with y particular double prime, and you will get 2a, right? And then you go from this and you plug in the differential equation, right? So y particular double prime is 2a, right? Y is that thing, right? So I'm just going to the differential equation. Then I get a t squared plus bt plus c. This thing should equal to 2t squared plus 1. Now, what you're going to do next, there are two two polynomials, so you have polynomial 1 equal polynomial 2. It is kind of, you are getting here polynomial equal polynomial, then coefficients should equal. Yeah, this means constant term is the same as, so this is a constant, 2a plus c equal 1. So the first thing is 2a plus c should equal the number 1. Yeah, so this is number 1, constant equal constant. Then the coefficient of a of t square is the coefficient of t square. Also you have here, so I'm just telling you that this thing and that thing should be the same. Then a is also equal to, and one more, b here, which is, I'm gonna say here, red, so this thing red, but here you don't have any t, right? Then you have 0 t, right? Then b should equal 0, then b should equal 0. Now we have the b, we have the a, and we have 2a plus c equal 1, but I have the a, I can plug the a here, and then from this one I get 4 plus c equal 1, then from this I get c equal minus 3, right? Then I got a, b, and c, and then my polynomial will be ready now, right? My polynomial will be ready. Then here is what we're going to have. I'm going to have y particular equal 2t squared plus bt 0t plus c, yeah, which is minus 3. Then I got 2t squared minus 3 is the y particular. It is by accident that the a, I got the same thing. I think I was here, we have 2, and I got 2. This is by accident, by luck, and this is minus 3, it was 1 there, yeah? Now we have y particular and we have y homogeneous, then we are done. So we need just to write the general solution for the differential equation is y equal, now you start with the homogeneous, it was c1 cosine t plus c2 sine t plus the y particular is 2t squared minus 3. Yeah? Yeah? So this one will satisfy, this is the general solution. Yeah? This one alone is satisfying the differential equation. It is a solution, but you need a general solution. This solution involves any solution for the differential equation. This is one solution for the differential equation in the question. But this one with C1 and C2 involve any solution. Any solution that you can give me, it will be of this form. Now let me just, before ending this lecture, let me show you if I change the equation to this thing. I'm changing the example to y double prime minus or plus y prime equal to 2t squared plus 1. What's going to happen in this case, when you go for y homogeneous, when you go with y, it is y homogeneous plus y particular. And if you go with y homogeneous, in this case, you will get r squared plus r equals 0. And then you get r times r plus 1 equals 0. Then you get r1 equals 0, r2 equal minus 1. From this, you get y1 equal to e power 0 t, right? T. And then you get 1. And then y2 equal to e minus t, and that's it. And then you get the y homogeneous here equal to c1 times 1 you get C1 plus C2 times E minus T, right? So you get the Y homogeneous here, and you know what to put here. Now, let's go with the Y particular now. Let me keep the homogeneous so that I can show you what is going on now. Here is first guess, Y particular now. First guess. What is the first guess? Y particular will be, as we said before, polynomial of degree 2, then you go with AT squared plus BT plus C. Now, if you continue with this, Y particular prime and Y particular double prime, and then you plug in the equation. So, you know, this thing was 2AT, and this thing was 2, I don't care, so whatever this is, right? And then if you go to the differential equation, the differential equation was R double, now it is Y double prime, right? Y double prime is 2AT. Oh, we need this, not I don't care, 2A, and here T, and here is B, right? So the first one is Y double prime plus Y prime equal to 2T squared plus 1, right? Now this is the Y double prime, yeah? And here is the Y particular prime is 2AT plus B equal to 2T squared plus 1, yeah? Now look here, here you have no T squared. It is kind of, when you compare, then you get for T squared, here T squared, here no T squared, here you have 0 T squared, right? And then you get 0 equal 2, right? It's kind of 0 equal 2, right? 0 equal 2, which is mathematically not true, which means that your first guess is not good. Why the first guess is not good? You can compare, right? Go to this and go to that, right? Go and compare. It says each part in the Y particular should be different from each part of the homogeneous. Now, but look at Y1 times C1. It is the same as this thing. This means that you need to multiply and adjust with multiplying by T. So you need to adjust and multiply by T. So the good thing, so this is not good. So because there is a match here, not linearly independent, linearly dependent, homogeneous and particular are linearly independent. For this reason, you go with Y particular equal to T times AT squared plus BT plus C. I'm multiplying by T, but if the independent variable is X, you multiply by X. You get AT cubed plus BT squared plus CT. And then you need to continue like this. What is Y particular prime, Y particular double prime? And then you plug these things here, this and that, in the equation, and then get your A, get your B, and get your C, and then when you get them, you put them here, right? Yeah? And then you have Y particular and Y homogeneous, and then you get the solution for this non-homogeneous differential equation. Okay, I hope that by this we have an idea how to guess our Y particular, and then how to use indeterminate coefficient method to find the constants. So when I go with these constants here, I'm using indeterminate coefficient method. So this method is called indeterminate coefficient method. I give you just two nice functions. I give you the exponential, I give you the polynomial. Next time I will give you trig functions, sine and cosine, and any combine between trig and exponential, or trig and polynomial, or polynomial and exponential. Okay, this is the end of today's lecture. Thank you very much for joining me in this lecture, and see you next time.